Hello again. We are in section 4.5 and we are going to be looking at problem number 1 today. And problem number 1, this whole lesson is dependent upon this concept right here, that the converse or just the isosceles triangle theorem and its converse. This page, which is right above problem 1, happens to say, but what it's really trying to say here is if these two angles down here, if the two base angles are congruent to each other, then the sides that are across from them are going to be congruent to each other. Okay? There's a definite correlation between the two sides and the two angles. So the corollary says if the two angles are congruent, then the two sides that are across from each one of those is going to be congruent. And the opposite of that is also true. If the two sides are congruent, then the two angles opposite them are going to be congruent. And remember, a triangle that has two sides congruent is called an isosceles triangle. So let's look at problem number 1 here. It's saying, is AB congruent to CB? So AB is here all the way down, and CB is here. Okay. Now, if we look carefully, across from BC or CB here, if you went all the way across, you would find angle A. And if you do AB here and you went all the way across, you would see angle C. And so since those two are congruent to each other, then AB and CB, by the converse of the isosceles triangle, which is what I just explained to you, says that those two sides would be congruent. So this whole side would be congruent to this whole side. Now I can mark that with like double tick marks so that you'll know. I just don't want you thinking it's that short piece. It's really this whole piece right here. Okay, so B part says, is angle A congruent to angle DEA? So it's saying, is this angle congruent to DEA, which is this angle right here? Okay, and again, since AD is congruent to DE, then the angles that are across from those would also be congruent. So since those are congruent, these two base angles would also be congruent. And that's truly just the isosceles triangle theorem. Okay, so let's look at problem number 1. Is angle WVS congruent to angle S? So it's saying, is WVS congruent to just angle S, which is this one. Now, for the same reason as before, because these two sides are congruent, then the angles opposite them would also be congruent. So the answer to that is yes, again, by what we call the isosceles triangle theorem. So angle S would be congruent to angle WVS. Okay. Now, can we conclude that triangle RUV is an isosceles triangle? RUV is right here. Okay, and even though we know that that angle is congruent to that one, we could prove that that's an isosceles triangle, the big one, but it's asking about this little one here. And sadly, we just don't have enough information here because we don't know if those two sides are congruent to each other. All we know is that angle. Now we know that angle matches that one, but we don't know that that side is congruent to that side. So we just don't have enough information for number 2 to really prove that that is an isosceles triangle. All right. Hope this was helpful and it makes sense about isosceles triangles. Best of luck.